Hello guys, and welcome to my 6th lesson on integration. Today we look at recapping points from lesson 4 and lesson 5. We look at how we can find the area below a curve. However, this time the question is slightly different, which means we need to approach it in a different way. So let's look at the question. It says find the area between the graph of y equals x cubed and the x-axis between x is minus 2 and x is 2. So, once again, this is an integration question. However, this time we're given an area below the x-axis and an area above the x-axis. At first, some people might look at this and be tempted to integrate between minus 2 and 2, all in one go. However, we can't do this, okay? Because we have an area below the x-axis, what will happen is the two areas, the one above and below, will cancel and we'll get 0. So we can't do that here. We need to split this up into the areas below and above the x-axis. So we're integrating twice. The first thing we need to do is integrate this function, because the x cubed graph is always going to be the same throughout. So we're going to get the same integrated function. So let's integrate x cubed. So doing this, we get x to the power 4, adding 1 to the power, divided by 4. Okay? Now we need to decide which values to substitute in as our upper and lower limits. Well, at first I'd suggest that we start with doing the part that we've done before, above the x-axis. We've done this in previous questions, we know how to integrate this. Our upper limit is going to be 2, and our lower limit will be 0. Okay? So we're integrating between 0 and 2 with this function. So, substituting in our upper limit of 2. Two to the power 4 is 16, divided by 4 is 4. Okay? Minus our lower limit answer. 0 to the power 4 is 0, divided by 4 is 0. 4 minus 0 equals 4. So this is the area above the x-axis. Now we can see if this is going to be a negative 2, we're going to get the same answer, just negative. But we need to show what we're doing, okay? In case in the exam we get a harder question where the values are not the same. So the next thing we do is look at the area below the x-axis. Now, we've not done a question like this before, but hopefully we can see we're going to have a lower limit of minus 2. Okay? This is the most left point on the x-axis where the area starts. So that's our lower limit. And our upper limit here is actually going to be the origin of the graph. The upper limit is going to be 0. So, now we have to consider substituting in our upper limit and subtracting our lower limit. So, if we substitute in our upper limit of 0, then we get, into this function, we get 0 to the power 4 divided by 4, which we've done before, that's 0. The next thing we do is substitute in our minus 2. Minus 2 to the power 4 gives us positive 16. We need to remember that whenever we substitute in a negative to the power 4, because it's an even power, we're going to get a positive answer. Okay? So we're actually going to get 16 divided by 4 again, which is positive 4. We have to do our upper limit, subtract our lower limit. So here we're doing 0, subtract 4. Well, 0 minus 4 is actually just minus 4. Now, what we have here is a negative area, and we can see why we've got that, because it's an area below the x-axis. But what we'd be having to do next in this kind of question is add these areas together. Well, 4 plus minus 4 is 0, so they do cancel. However, all we do is consider this minus 4 as a positive 4. The only reason it's negative is because it's below the x-axis, so we can just consider this positive for now. In reality, if we looked at vector quantities, for example, we'd see that this would be possible to have a negative part of a graph. For example, you might have done something like that in physics, where you look at speed against time and velocity against time. Well, speed is a scalar, so you won't have an area below the x-axis which is negative. However, you will when you look at velocity, because it's a vector quantity. Okay, so that's the context of it. But with this, we just consider this a positive 4. Okay, we don't need to write the negative. So now we just add the two areas together. So this is our area enclosed by the graph in the x-axis between these 2 points, -2 and 2. So the area is 8, okay? So this is a rather difficult question to think about, but when you're applying the integration, it's just the same really as any other question we've done. So you might be looking at 4 to 5 marks here in an exam. So that's lesson 6, guys. That's our recap on integration. This is our final lesson on the topic. So feel free to ask me any questions if there's anything you're not sure about on integration. Next we'll be looking at polynomials and how we can factorise polynomials and define them. So thanks a lot, guys. Please put a comment below, and if you liked the video then please subscribe to my channel. I'll see you in the next lesson on polynomials.